Okay, so this is the point. I'm going to start with our first number, which is not 1, but 2. After 2, we can only ever get 3. And by the way, let's just say right here, we want to be in 9 limit. So we start with 2. 2. Our next answer is 3. Before we go there, let's say 2 plus 3, which is going to be 5. Before we go there, we can add 5 and 2 and get 7. Or we can add, before that, 2 and 7, we can get 9. So let's get 9. Right? 9. Now 9 minus 2 is 7. I don't want to add 9 and 7 together. 7 minus 2 is 5. I don't want to add 5 and 7, so I'll put 5. Now, 5 minus 2 is 3. I do want to add 5 and 3, because that's 8. 8 is not too high. 8 plus 3 is 11, and 11 is too high, so we're going to put 3. Now that we have 3, our only next answer can be 4. 3 plus 4 is 7. 7 is not too high. 3 plus 7 is 10, and 10 is too high. So we'll put 7. Now, 7 plus 4 is 11, and 11 is too high. So I'll put 4. Now that we have 4, our only next answer is 5. 4 plus 5 is 9. So I'll put, and 9 is not too high, so I'll put 9. 9 plus 5, now 5 plus 9 is 14. And that's too high, so I'll take 5. After 5, our only next answer is 6. And actually, 5 plus 6 is 11, and that's too much. So, I'll put 6. Our next answer is 7. Could only want to put 7. 7 plus 6 is too high, so I'll put 7. Same thing for 8, because 8 plus 7 is 15. And finally, I'll put 9, because I don't want to add 8 and 9. That would be 17. These are all the nodes that you have available on the string, so let's divide these up. 2 of 1 and 1, 3 of 1 and 2, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, 1. Those are all there. And you'll notice why I stopped at 9, because it has that really nice octave, sounding octave. And of course, 9, 8 is a major second. 9, 1 is octave displaced major second. So that's why we stop at 9. That's why I like 9. Same thing for 3. I like 3. And same thing for 5. I like 5. Let's fill the rest of these in. This is obviously 2 plus 3 is 5. 1 plus 1 is 2. And 1 plus 2 is 3. And 2 plus 3 is 5, as we know. Here, 3 plus 4 is 7. 1 plus 1 is 2. Again. And 2 plus 3 is 5. So, that's it for that row. Of course, here, 2 plus 5 is 7. 1 plus 2 is 3. And 1 plus 3 is 4. Same thing here. This will be our, this sounds as a perfect fourth with the intervals of 7/4, which is a flat 7, and a 7/3, which is a flat third. So this is a very 7 limit bluesy sound. And so is this, right? Obviously, 5 plus 3 is 8, 2 plus 1 is 3, and 3 plus 2 are 5. Anyway, 4 plus 5 is 9, 1 plus 1 is 2, and 3 plus 4 are 7. Isn't that... Did I get that wrong? Maybe this could have gone up in the top row, but yeah, I think so. Anyways, that about does it. This tells you, obviously here we'll have a perfect unison sounding at the octave, octave and an octave make a unison. Here, a 3/1, which is a fifth, plus an octave or 2, and 3/2, which is just a regular root position fifth, sound an octave. I'm sorry for the octave displacement, like not knowing. It's kind of funny. It's a lot of octaves, but anyway. I mean, so, if our string is E flat, then obviously this is going to be an E flat, this is going to be an E flat, this is going to be a B flat, B flat, this is going to be an E flat over A flat, and these are going to be tuned slightly differently. So this is going to be at pitch, this is going to be plus 2 cents, this will be plus 2 cents, this will be at pitch, this will be minus 2 cents because it's an A flat. Here we're going to have G natural and G natural both minus 14, minus 14. Totally running out of room. 6 of 1 and 5. That's going to be our minor third. So this is like G flat with B flat over it, because a 1/5 is a major third. 6/5 is the sixth partial tuning, which is plus 2, minus the partial tuning, the fifth partial tuning, which is usually subtracting 14 cents, but because it's in the back stack of this kind of tile, a 6/5 is 2 minus negative 14, which is 2 plus 14, which is 16 cents. So this G flat is plus 16 cents away from E flat because it's a 6/5. That's kind of what we're going for. That's kind of where it's at. Does that make sense? Like, say, take this one. These two. This is a tile represents two pitches, a high pitch and a low pitch. The high pitch is called 8/3, and it's the distance between the 8th partial and the 3rd partial, which is a pretty big distance, right? It's like an octave plus a 5th. Maybe. I don't know. I don't remember. 3/8, it's an octave plus a 4th. Okay. So an octave plus a 4th away from E flat is A flat. Let's put it. Now, if we're tuning this A flat, we know that, let's do a table right here. The first partial is, I guess, plus or minus 0. If we're talking about overtones. Same thing for the second partial, plus or minus 0. Maybe it goes that way. The third partial is always plus 2 cents. Fourth partial is always plus or minus 0 because it's an octave. Here, we'll put it this way. That looks better. Octave, octave, fifth. You can look this up on Wikipedia. Octave, of course, 5 is always going to be minus 14. 6 is plus 2. 7, I think, is minus 31. And 8 is always at pitch, plus or minus 0. So if we're measuring the distance of an 8-3, we're going to use the big 8 and the small 3. Big 8 is 0, and small 3 makes take this and flip it. Means take this and flip it. Minus 2. So plus or minus 0, minus 2, big 8, little 3 comes out as minus 2. Same thing for big 8, little 5. Big 8, little 5 is plus 0, plus 14, which means plus 14. And of course, the distance between the 8th partial and the 5th partial is a minor 6th. So a minor 6th up from E flat is C natural, right? I think so. I'm pretty sure. Nope, it's C flat. And of course, our distance between A flat and C flat is the same as our distance between the 5th partial and the 3rd partial. Whoa, crazy.